Hi fellow developers. Today I want to show you an interesting memory leak issue I encountered recently around React hooks which are used for performance optimizations like useCallback, useMemo. Developers often have a habit of overusing these hooks, which increases the risk of these memory leaks even more. These memory leaks are formed by closures, and they can appear when you have a combination of large objects like large response object or large state object in combination with these memoization hooks, useCallback, useMemo, in your React components. I'm going to walk you through some code examples and try to explain what's actually happening. But first, we are going to briefly refresh our memory about closures. So, what are actually closures? First, we need to mention that closures are not exclusive to JavaScript only. They exist in other languages too. So, what are actually closures? Certainly, they're one of the most popular questions in technical interviews. And there are many definitions out there about closures, but I really like a definition by Kyle Simpson, this legend over here. So by Kyle, closure is when a function is able to remember and access its lexical scope, even when that function is executing outside its lexical scope. What does this actually mean? It means that function or functions are able to remember the variables which were in the scope at the moment when they were created. I made two examples here to explain what's actually happening. So if we take a look at this first example, create greeter function, the closure is actually formed around this inner anonymous function. So this inner anonymous function is able to access or reference the greeting, the time step, and also the name variable at the time of execution. So you can see here. In this second, a bit more complex example, we can see that closures can also be nested inside of other closures, which provides them even larger scope. JavaScript closures are implemented by using context objects that holds a reference to the variables which are actually in the closure. Which variables get actually saved to the context object is an implementation detail of JavaScript engine and is a subject to various optimizations. We can easily see these context objects in. So if we jump to the stack blitz example and place debugger over here, save the page and open example in a new tab, inspect the page to open developer tools and reload to activate debugger. Under scope in developer tools, we can see under local scope we can see function, reference to the function variable, which actually points to third function from our example, so this inner function over here, and we can see that this function is forming closure over these two variables, so first var and second var. So if we get back to developer tools, open this reference, and under scopes we can see actually these context objects or these closures formed over first variable and second variable. So as long as app holds a reference to the function, none of these variables in the closure will be actually garbage collected. Due to scope chain, like here in our example, scope chain, even outer function scopes will actually remain in the memory. So when we know how actually closures are working and that we can see them inside of browser too, we can jump into React. Now when we are back again in presentation, let's see how closures are formed in React components. In React we actually rely very heavily on closures for all functional components, hooks, and also event handlers. Closures are particularly important in React because they are fundamental to how React components maintain and access their state and props. Let's see this in example. So here we have a simple example of an app component with a handle click event handler and the user effect hook. I suppose that now you can easily spot closures. So handle click event handler will form closure, but also use effect will form closure, and they will form a closure over count variable from state and also ID variable from props. In most occasions this is not a problem. These closures will be created and recreated on each render of app component, and the old ones will be garbage collected. We have some referencing and dereferencing, but this will in the most of times will not form any kind of performance issue, because garbage collecting is pretty performant in JavaScript, or JavaScript engine is doing great job of garbage collecting. However, when we start using memoization techniques like useMemo and useCallback to avoid unnecessary re-renders, we have to watch out for some things. Here in second example, we are using useCallback hook to memoize handle my event handler. useCallback will hold a reference to the function as long as its dependencies do not change. So here we have a count variable or count state as dependency. So until a count variable doesn't change, reference to the handle my event will not change. We want this, of course, to avoid unnecessary renders. In this example, we are actually avoiding unnecessary renders of this expensive component, and we are doing this by keeping the function reference stable. So far so good, right? But let's spice a bit this situation in next example. So if I scroll a bit, here we have a very big object. It could be big state, big response object, big image, or something similar. Its size here in example it's about 10 megabytes of data, and I'm using here 8-bit array to simulate the size of the data. Can you guess what actually happens here? Since handle my event creates a closure over count variable, it will hold a reference to the component context object, and even though we never actually access the big data in the handle my event function, handle my event will still hold a reference to the big data. So big data will never get garbage collected essentially as long as handle my event is being referenced, and in this case the reference will hold until count variable changes and new reference or new handle my event function is created. We can see also this example in the browser, so we are going to jump again in Stack Blitz. So now when we are in Stack Blitz again, we can see the same example from presentation. If we add debugger over here and open this app example in a new tab and inspect the page, reload the page, again under scope we can see handle click reference to the handle click event handler, and if we open this property under scopes, we can see form closures or context objects, and under app closure we can see that we have actually references to these three variables, but also the reference to the big data object. So already now you can probably guess where the problem can appear. So we are going to have a look on one last example that will be a bit more complicated. So if I jump back again to the presentation, so in this last example we actually have two memoized event handlers, handle click A and handle click B. We also have handle click both function, which calls both of these event handlers and also log the length of the big data object. And can you actually guess what happens when we start clicking on button A and button B, or on the increment both button? We are going to, because we can easily see what's happening if we do the memory profiling, we are going to jump back again to the stack blitz to do the memory profiling. So we are going back to the stack blitz, and here we can see the same example. So if we open this example again in a new tab, we can see these three buttons, and if we open DevTools and start actually memory profiling and do the incrementing, so I'll alternately click on one and then another button. If I stop profiling and search for the big object, we can see that actually the reference to the big object is kept. So actually big data from the example it never actually gets garbage collected. So sorry, the memory usage keeps growing and growing with actually each click. So we are actually in some kind of repeating chain of references. So I'll walk you through each step. Bear with me, because it can be hard to follow because of this chain of references. Now when we are back again in presentation, it will be easier to follow if we take a look on this image. So when app is created or is rendered for the first time, the app component it creates a closure scope that holds references to all the variables, since we actually use all of them in list one closure. So this includes big data, count A, count B variables, also handle click A and handle click B event handles. And let's call this closure app scope 0. When we click for the first time on increment A button, this will cause handle click function to be recreated, because we are changing the count A variable. So a new function will be created. Handle click B will not be recreated, because we are not changing count variable count B. And this means actually that handle click B will still hold a reference to the previous scope, so the app scope 0, because of memoization it's gonna hold the reference to the previous scope. The reference to the function did not change, but handle click A will now hold the reference to the new scope, app scope 1, new scope which is created after re-render of app. Now when we click on B button, increment B button, this will cause handle click B to be recreated again because dependency has changed, so the reference for this function will be recreated. But we will not recreate the handle click A function because count A variable dependency of useCallback for handle click A function did not change. New handle click B will then hold a reference to the new scope, app scope 2, which then holds a reference to the handle click A, right? which holds a reference to the app scope 1. But app scope 1 also contains a handle click B, and handle click B holds a reference to app scope 0. So we can now see, easily spot this chain of references between re-renders, between these newly created scopes and these memoized functions. So the general problem here is that different useCallback hooks in single component might have reference each other, like we have here and here, and because of these references we are actually creating this chain. And if we also have some large data, expensive data through these closure scopes, then we can have this memory leak problem. So memory usage will will be increased in each click, on each action actually. So the more callbacks you have, the more likely you will encounter this issue, especially if, of course, if these callbacks are memoized. So will you encounter this issue in your app? This really depends, but now you can probably see when these issues can appear. So if you heavily rely on useCallback to minimize re-renders, if you call other functions from your memoized functions, if you, like I mentioned multiple times, if you have large objects like some kind large response object, large image object, or large arrays or something similar, the probability is certainly higher. But of course you can avoid this problem by keeping closure small. What does this mean? This means that when you write components, you can try to write smaller components. When you have some custom logic, use custom hooks, because when you write a custom hooks, you are actually reducing the scope to just that function, which is actually avoiding this forming of this chain of references. You can avoid capturing other closures, especially if they are memoized. So we have seen this in this last example. And there is, if you have large objects, you can also try to solve this problem by using a useRef hook for keeping a reference to the large objects between re-rendering, between component re-render, and you need, in this case, of course, you need to handle the life cycle of these big objects by yourself, because useRef will not update itself between re-renders. Now at the end you can see that these issues could be very sneaky ones. I hope that this video will help you to be more aware about these potential issues around performance optimization, hooks, and memoization. I also hope that you like the video, and until next time, bye!